Hi, so welcome back to the part about life insurance contracts in problem 3.8. What we're gonna do in part 2 here is talk a little bit about the 3 different products that are introduced in chapter 3. So the pure endowment, the term insurance, and the temporary life annuity due. Now in this video in particular, we will talk about the pure endowment. So just to try and get you guys understanding what is going on, and we will take the book and just start from there. So what is a pure endowment insurance? Well, a pure endowment insurance, it kind of needs a bit more words than just pure endowment. So what I'll write here is this. So for an X-year-old who buys a pure endowment insurance with expiry N, we have that the amount 1 will be paid out at time N. So the amount 1 will be paid out at time N if she is alive at time N, at time N, and if not, no payout. So how do we look at that? Well, the way we look at that is we can kind of think of 2 scenarios. You guys might recall that in chapter 1 we drew timelines where we kind of also drew payment streams. What we will do here is also draw timelines, but since the pure endowment insurance has payout depending on whether or not you're alive at expiry, then we will actually have to draw 1 timeline for each scenario because we have 2 scenarios. So in both cases, we have someone who is X years old here. So this is an X-year-old. And the person buys a pure endowment insurance with expiry N. So there are 2 cases. There is the case where TX, the remaining lifetime, is smaller than N. So that means that our X-year-old will die before expiry. And then there is the other case where our X-year-old survives past expiry. So in the first case, if she does not survive past time N, there is no payout. Then everything is just 0 up here. In the second case, if she survives past time N, then what we see is that the amount 1 will be paid out. Now let's look at these 2 cases. The reason why there are 2 possible scenarios is because Tx is a stochastic variable. Now, what is the probability of scenario 2 down here? Well, the probability of an X-year-old surviving past the next N years, well, that is exactly the conditional survival probability, right? So what we have down here is that the amount 1 will be paid out in N years time with the probability NPX. And with the probability 1 minus NPX, nothing will be paid out. So this is one part of it. Using these 2 probabilities, we can actually find the value of the expected payout. So the expected payout is equal to, well, we just take the probability of each case and how much is paid out in each case. So in the first case, 0 is paid out. And in the second case, you have this conditional survival probability, and 1 is paid out. So the first term is just 0, hence the expected payout is NPX. Now we can ask one more question. Well, the NPX in expected payout, it is not paid out now at time 0, it is paid out in years. So the present value of that is different, right? So the expected present value of payout well, that is equal to the NPX, where we have averaged to take care of the uncertainty there is because of the lifetime being uncertain. And then we also have to discount this amount in years back in time. So we have e to the minus delta n with the discount factor. So if you look in the book, this is actually what they call v of 0. I think in the book they write TEX is equal to e to the minus delta t TPX, and this is equal to v of 0 or something like that. So the only difference here is I have chosen n to be the expiry instead of t. So this thing here is NEX, where the N stands for the date of expiry of the pure endowment insurance, and the X stands for the age upon drafting the contract. And the E probably just stands for expected value or something like that. So just to sum up in words, what we have found here is in fact the expected present value of a pure endowment insurance. Now, another question. Why is this even interesting? Well, again and again and again, you will be interested in finding the expected present value of a life insurance contract. And the reason for that is by finding the expected present value of a life insurance contract, the life insurance company will know how much money to set aside in order to meet their future liabilities. So this does not work if the company only has one customer. However, if the company has 100 customers and they know the probability that they will survive the next n years, then for example, if it has 100 customers and it knows that 10 of these customers will die within the next n years, then it means that they also know they will only need to put money aside for 90 of them. Hence, we need the probability of survival. And also, and also the discounting part is because they don't need to put the exact amount aside. They can put a little less aside since they can let that amount of money accrue interest over the years. So this is why we're interested in the expected present value of a life insurance contract. It's because this is equal to the amount of money that the insurance company needs at time 0 to meet future liabilities. And this is also what notation-wise we call v of 0. And just to round off this exercise, not exercise, but this explanation of pure endowment, the official definition of v of 0 is the mean value of the discounted value, so the expected present value of the payout, which here I will denote as B, where B is equal to 1 if TX survives past N, right? So this is the official notation in the pure endowment case. In the next video, we will look at payment streams. So I apologize that these videos are kind of long and drag out, but I feel like if you really want to have an understanding for this, It's also important to go into the details. So in the next video, we will look at payment streams, which means that instead of B just being the number 1, it will be able to vary over time and take on different values over time, such as either 0 or 1, and that will be the next video.